We've got bins on our .NET MAUI Maps app. We've got location data, but what we don't have yet is anything useful. So today, we're going to bring this app to life. We'll get live location updates, work out the closest bin, and even draw a little route to it. So your dog isn't left pacing impatiently while you guess which way to go. We've done the groundwork. Now let's make it clever. I'm Chris. Welcome to Coding with My Dogs. Coming up, I have more fun with AI. And of course, it doesn't exist. It's been made up by ChatGPT. I go from periods of less success, bugger, what went wrong there, to periods of greater success. 329 meters, and we're at our nearest poo bin. That's brilliant. And throughout, Mr. T wears his comfort blankie. What I want to do next is to pave the way for our route finding. So to start off with, we're going to do some a little bit of refactoring of the location service. In the location service, I want to change it so that we also have the option to have a live feed of the location coming back from that service to whatever needs to subscribe to it. So that's going to be our view model in this case. That live feed will be via a observable, and that observable will be based on a timed interval. I think we'll start with 5 seconds. So every 5 seconds, it will get the location and then push that location through the observable to anything that wants to subscribe to that observable. In addition to that, we will change the presentation of the map control to add a little crosshair to show what our current location is. And that then gives us the ability to wire up that observable into a property change notification from our view model, and then have the map updating live and showing our location changing. Let's start with the location service itself. So if I share my screen, we are back in our Visual Studio solution. And if we look to the location service implementation, no, that's not the right one, is it? I hadn't noticed until now that we've got a very confusing naming of the bin location service and the location service. We need to sort that out because that's pretty confusing. So let's change this to maybe to the bin data service. Bin data. Okay, that's a useful bit of refactoring done before we even start. So back into the location service. So we have our get current location async. And as we can see, it's basically doing the permissions check. And if we have permission, then it can go and get the location, telling it what accuracy we want, and a timeout for the location service as well. Our exception handling is just that we return null. So as well as having this get current location, we will then also expose a property, which is an observable. And for that property, we will then set up behind the scenes. There will be a subject, which is the basis of the outgoing observable. And within the subject, we can then we can set up a timer loop, which will then push our changes out onto that subject. So as always, I'll get Copilot to do the donkey work for that. And then we can look at what it's done and make any tweaks that we need to do. Possibly we will do. Up till now, we've always needed to change something, but let's see what it can do. Let's go in here. Let's go to a Copilot edit thread. I'll be very specific about what I want done. I don't want it to go and change lots of files. I want it to change just the location service for the moment. Later on, we'll get onto other things. Please add an observable to location service. This should be exposed via a property on iLocation service, and internally we should have a subject of location. add code to get the location every 5 seconds, and push the new location, if it has changed, out over the observable. Make location service implement iDisposable and use dispose to stop the location service timer loop. So modifying iLocation service interface to add iObservable of location and implement iDisposable. Great, that looks good. Update location service class to add system reactive, implement subject for location, timer field, location polling logic, location change detection. Okay. Implement iDisposable pattern. So that's good. So iLocation service, it implements iDisposable and adds for us this iObservable location update. So that looks good. And back into the location service itself. Ooh, okay. So bringing in system reactive subjects and system reactive link, implementing iDisposable. So at the top of the class here, we are creating our subject, having a timer, which is itself iDisposable, keeping track of whether we have been disposed, and then keeping track of the last location that we saw. This is good. The property that we expose is just taken directly from that location subject. That's brilliant. That's what I'd expect to see here. So in the constructor, we create an observable timer starting from 0 and ticking every 5 seconds. And that basically subscribes to update location async. Okay, brilliant. Yeah, so update location async is going to call into our existing get current location async, and then saying if it's not null and if it has changed location, then update last location and then push that location across the observable. Okay, that's excellent. Location has changed. It's basically doing very nicely here. So it's calculate distance from the last location to the new location and checking to see if it's more than whatever that is, 10 meters or something. In fact, it does say in the comment more than 10 minutes. Great. More than 10 meters. So in dispose, okay, it's implementing the disposal pattern, dispose true, and then suppress finalize if it's called on the main one. And then if we haven't already disposed and we're disposing, it disposes the timer and the location subject and sets is disposed to true. So that looks good to me. Let's click on accept all there. It hasn't brought in the NuGet package. System.reactive. And we were using system.reactive.link, weren't we? So let's just bring that one in. Seems happy. And that seems happy. Let's check that we build. And we do build. Very nice. Okay. So as I said, the second part of this is that I just want to make a quick update on the user interface itself. Previously, we added the mapping markers that showed where all the bin locations are. In exactly the same manner, I want now to add the current location as some sort of cross. I believe that's supported. And let's make it blue, shall we? A little blue cross in the middle of the screen, which will show where we are, which means as we now move into an updating location, we can clearly see that little marker moving with our location. So let's get on and do that. We need to go into our main page .xaml.cs and remind ourselves what we did in terms of the location. In fact, we were doing it from within the view model, weren't we? So let's go across to that. Our main page view model. We have our update marker layer, which we call into. That gets the bin locations and plots those. What we therefore need to do is to plumb in our location to that. And do you know what? In fact, I think in terms of the way this code is laid out, I think it probably makes sense to go and bring in our observable first so that we have got something that ticks every 5 seconds or whenever the location changes. And then we can use that as the basis for when we update our location and therefore when we change the marker that gets displayed for our location. So let's do that instead. So from our location service, we get it here. So we basically want to subscribe to the location service. And every time we get a new location, we'll update marker layer and we will pass that location into update marker layer, which we weren't doing initially. So okay, let's see what magic it has got for us here. Okay, that's kind of interesting. So it decided that what we want to do is when we get a new location, and that location isn't null, we do the usual stuff of getting the Mercator point from the lat long for that, and then centering on that new coordinate and zooming to the required zoom level. I would say we don't necessarily change the zoom level from what the user decides to move to. So let's just remove that bit, but the rest of it can stay. And from there, we can call update marker layer. And this time, update marker layer will take in a location. Location, that is fine. And we can say update marker layer with our location. That looks good. We've got our memory layer, we've got our markers, we've added our features to it. So let us let's get that as a list so that we can therefore append to it the current location. So we are adding a new point feature. Again, getting our point from the Latin long. We are going to change this to be a symbol type. There's no cross. Okay. I thought this allowed a cross, but let us just say a triangle then. Triangle. It is going to be blue, which is what we said. And outline in blue as well. Symbol scale, we'll try 1.0 for this. We may need to go back to that as we did previously. But anyway, that is updating our features as required. I have one concern with this in that we are basically replacing this entire set of features every time a new location gets posted. I don't know if that's the canonical way to do it with MAUI. We'll just have to see how this works. We may need to circle back to this and think of a more canonical way to implement this if this isn't the right way to do it. But hopefully it'll work. So we've got everything we need in place now. Let us just try building that. Okay, so that builds. Okay, let's run that up and see what we get. Yeah, our triangle is too big. We thought it might be. Okay, so that's fine. That shows where our current location is. I need to also give it a route. How do I add that to the route? So walking route, starting from here. Finishing here. Save route. Play route at 1 times. Okay, so as suspected, once every 5 seconds, the map updates and gives us a completely new marker in each location, but doesn't remove the previous ones. So that is disappointing. And I'll place a bet that's adding a new one of these every time as well. That said, our location service is working. We can see once every 5 seconds we get this new location coming through. So let us stop that. Okay, a couple of changes we want to make here. We want to go to the view model. You can set that marker size down to 0.4 as well. And then we need to have a think about this. So is there a features.clear or something? Features thinks there is, but in reality there isn't. So this just looks like a normal collection of some sort. Data has changed. Maybe, I'm thinking probably not, but maybe. So we are creating the marker layer from scratch here, of course, aren't we? So the marker layer itself obviously will not need to be cleared because it's brand new, which we've just put this stuff in. But what we are doing is we're adding a new layer to the map model, and we should not be doing that. We should be replacing the layer that's already there. So what can we do? Let's see if Copilot can give us some insight into this. I'll just ask this as a question. I don't want it to actually make any changes here. In line 97 of the main page view model, we're adding our marker layer as a new layer to the map itself. I actually want this to replace the marker layer if it's already there. Is there a canonical way to do this? We can just see in the first part of its result there, it's saying that we can look up from the existing layers for one that has the name of our marker layer, remove that one, and then add the new one. So I think we'll do that. So where we've got layers to add marker layer, just before that, we can say, and we may need to, there's a lot of stuff happening within this method now. We might want to do a bit of refactoring of this a bit later, but let's just do this. So let's just copy that code in. We'll just bash it about a bit. So existing marker layer is our map model at layers first or default, where layer name equals markers, which is what we called it. If it's null, we remove it, and then we just go and add our new marker layer. So that should do the trick. Let's run that up, and I think we can be done with this particular session if this works. Our location has changed to the correct size. Let us play that route again. And that was encouraging. It looked like it changed to the new location. Fantastic. I think that's doing what we were hoping it would do. That's great. So with a bit of fiddling around and a bit of faff, but we've learnt a bit about how MAUI works in this way, how we're supposed to make these modifications to layers, etc. So we're now in a situation where we have our location updating live once every 5 seconds. And now we can move on to doing the real parts of this application. We need to be able to go and take the location that we're at and the location that the nearest bin is at. And we then need to find out the segments of a route that go from one to the other. And we'll use another library to achieve that purpose for us. And once we've got that, then the final part of this particular coding session will be to take that route and then to display that as another layer on this map so we can see an overlay of the route that we want to follow. That will do for the moment. But now let's go and take a look at our whiteboard. We need to see what we need to do in terms of calculating our route and then plotting our route. Let's go.
Okay, Mr. T, third time lucky. I need you to be razor focused today and concentrate on everything that I show you. Is that okay? So, first of all, we need to enable live updates for our route. That way, as we move around, we can see our location changing and we know where we are. And secondly, we need to get the route down from the open route service. And what we'll do is we can then get the route to each of the poo bins and we can work out which is the nearest. And then finally, what we then want to do is once we've worked out where the nearest bin is, we then want to plot the route that we take on top of the map so we can see which direction we need to go. How does that look, Mr. T? I don't believe it. You've fallen asleep again, haven't you? Oh well, let's get coding.
In this session, what I want to do is to integrate with an endpoint the Open Route Service API. We'll use this endpoint to take a starting location, a bin location, and determine the walking route between them. We'll start off by looking at the Open Route Service API. And they have a demonstration on their webpage. So let me share the screen and we'll take a look at that. So what I've done here is that I have taken a couple of start and end locations from our Hyde Park map where we've got the phone emulator set up. And here we've basically got the get endpoint for this direction service. That basically takes a set of query parameters which define the API key. Don't worry, I'll be changing this before the video goes live. And those start and end location coordinates. It also takes as path parameters the profile that you want to use. And in this case, we're not driving a car, we're walking on foot, and we need it to be able to understand that it doesn't have to go via roads, it can go via footpaths. So to do that, it took a little bit of investigation to find the right code to use for this, but we say foot walking. And that's basically all that we need. If we click on call action here, you can see below that it has plotted a route on the map from our starting location, which I input, following various paths and ending up at our end location. And we can basically look at the JSON that this produces. This gives us features And within the features, we can look at properties. Properties can give us a route summary, which we're going to be interested in. Specifically, this tells us the distance in meters that the entire route takes. Then it shows segments for the route. And within the route segments, so we've only got one segment here, which is the entire distance. And then it will show what would potentially be spoken instructions if we ever wanted to do that. We're probably not going to go that far, so we don't need to really worry about this. It shows us waypoint indexes for each of these route segments. We may or may not need to look at that, and I'll show you why in a second. So that gives us the entire route there. But if we look down here, this geometry section gives us 13 items. That's each of the waypoints that are mentioned by index on the route above. So basically, that's great. The next thing to do is to go into the code. Once we're in the code, we can add a new service for this. We're going to call it from within the map code to go and give this route service a start location and an end location and to give us all of the route segments in between. So let's get into Visual Studio and see what we can do with this. We're back in our solution here. It's exactly as it was at the end of the last session, where we've got the live updates for our locations. Now, what we want to do is create a service called something like Route Calculator and put that behind an interface, iRoute Calculator, which we can then use to plug in via dependency injection wherever it's required. So let's start off with that. We're also going to need some model types for what gets returned from our route calculator. So let's go into Copilot and ask it to create just those specific things that we want for now. We'll later get on to plumbing in the get call into the Open Route service. Please create a new service, Route Calculator, and an interface, iRoute Calculator. Please create a model record type for route location, just latitude and longitude, and a record type for route, which is a list of route locations and a double total distance. For now, add a single method to Route Calculator, calculate route, which takes a route location for the start and route location for the end and returns a route. Let's start from the bottom. Route is there and its record, which is a list of route locations. We'll change that. And the total distance, route location, as we said, lat and long. The iRoute Calculator just has calculate route and it returns a route. And then placeholder implementation here because we are not doing anything with it yet. So let us accept those changes. Just do a slight refactoring in the route itself. These are not locations, but waypoints. It didn't modify MAUI program.cs for that, did it? So we need to add singleton. Yeah, that's fine. So it knows what we wanted. Okay, that's great. So the next thing we need to do is to get some configuration in place for the API itself, because the API needs to have its base URL, which is the one that we were calling into there. It also needs to have this API key. Now, we are in a danger zone here because what I'm developing here is a entirely client application. This is something that runs on an Android or iOS phone. And it means that if we put this key into our configuration, no matter what we do to try and protect it, it can always be extracted by someone who is determined enough. And for something like this, it's maybe not too critical, but we can certainly, if someone got hold of the key here, we're only allowed to make so many calls into the API in a certain period of time. It'll get throttled otherwise. So if someone was able to get hold of this key, then they could at the very least give us some sort of denial of service. And of course, if this was a service that we were paying for, then they could get free use of it whilst we are footing the bill. So that's clearly not something that we want to have happen. In reality, if we were developing this up as a real application that would be distributed to the general public and made available for use, we'd have to do this a different way. We'd have to have the the calls into this route planning service would have to be done server-side somewhere. So we would maybe have an Azure app service or a function app that runs that can take the credentials of a user who has registered with our application and then basically on their behalf and using some sort of protection against denial of service or throttling or whatever we need to do, go and make the call to the Open Route Service API by itself and then return via that function app or app service the route back to our mobile application. And that way, the mobile application never has to have any of these keys stored within it. It's all done server-side and it's completely separated. And by having some sort of user registration process, we make sure that it is not feasible for anybody to be using our route planner for some nefarious purposes. That's not something we're going to do in this demonstration. So I will just have to put this API key in our configuration somewhere. But bear in mind, this is not something you'd ever do for a proper production application. And if for some reason we ever decide to take this Bin Tracker application and make it a production app, then we'll have to do everything that I just mentioned to make sure we've got some level of protection here. So let's look back at our Copilot, and we want it to add that configuration for us and then make that configuration available within the route calculator so it's got everything that it needs. Okay, I took a quick break to try and resolve the issues with configuration. Basically, it turns out that within MAUI, there's not necessarily a specific way to do app config, probably for the reasons that I mentioned, that, it all gets packaged up within the application. It's not like users have the ability to go in and tweak these settings as you do when you're looking at a desktop application or a server application. But there are ways to do it. So I've basically taken an example of that, put a link at the top of the MAUI-program.cs so you can follow that and have a look at what's actually been done there. But it's pretty simple. It's just loading in a JSON file, which happens to be our config file. And then we're extracting the one bit of config that we need from that, registering that as a singleton so it's there and available to inject into our route calculator service. So let me just share the screen again. We'll take a look at that. That's the link I was mentioning. And we are basically getting the app settings.json as an embedded resource, building configuration based on that. And then from that config, getting the section that we want for the route calculator options. And then that itself gets bound as a singleton so it's available for our route calculator service, which is here. So constructor injection, we get those options in, and then we can collect our base path and our API key for use whenever we want to. Now, the next step obviously is to actually call in to this service. So let's take a look at the service config again. So our base URL is this one, https API key. As I mentioned, by the time this video goes live, this API key will no longer be valid. Okay, so there's our base path, there's our API key. We can then collect the rest of the path that's required for the get endpoint. Okay. Put dash walking. Okay, lovely. So we've got our base path, we've got our API key, and this particular endpoint that we need to go to is this one here. We may as well get back to using Copilot here. Please add a private method here, which will call the get endpoint for our Open Route service. Use base path and route endpoint to build the URL we need to call. It will be passed a start and end route location. The call will need 3 query parameters: API key, start and end. Start and end will take a string, which is a longitude followed by a comma, followed by latitude, for now, return the JSON response as a simple string or null if the call fails. Okay, so we have call open root service async, start and end location, optional string, asynchronous result. We're building an HTTP client, constructing what we require for the start and end parameters, constructing the overall URL. Okay, and just inlining the various parameters. I mean, I think this will do for us. And then it's just swallowing exceptions at the end. We'll take a look at that in a second. The other problem is it's just concatenating base path and root endpoint. I think we need to make sure there's a / in there somewhere, which currently we don't have. Let me just accept that. App settings.json. We will just make sure there is a / at the end of that base path so that things get concatenated properly. Okay, so we're using HTTP client, so that will get disposed when we leave the scope. So what we can do is in calculate root, we can just call into this. It's all async actually. Async task of root, which is fine. We'll need to update the interface to do that as well, and we can await on that. I just want to check that we can call this, so we'll just run it up under the debugger and see what we get in the result. Then we can start thinking about how we handle relatively complicated JSON response from this. I think we can make use of Copilot or maybe even ChatGPT to do that. We can just feed it the entire set of results that we get from calling in the demonstration portal for Open Root Service. We can collect that JSON and then ask ChatGPT to generate the minimal type that we will require to be able to deserialize that JSON into just what we want. In other words, we want the set of waypoints along the route, and we want the overall route length. That's all we need for the calculations that we're going to be doing here. That should at least allow everything to build, but we need to actually call into this from somewhere, which we're not doing at the moment. So let us go to the view model, and I think what we'll do is we'll wire it in and have that button click calling into this route calculator to calculate the route from the user's current location to the first poo bin in the list. Let's just do that for the minute. Obviously, later on, we're going to go through all the poo bin locations that we have and find what the minimum distance is and then use the route that we get from that. But that's the next step. Main page view model. Remind ourselves what we've got in here. Basically, the things for updating the marker layers. And this counter text that we're not using anymore. So we'll be ripping out this on counter clicked and the counter text, and then we'll be repurposing that button for our find nearest poo bin. Gives us that counter text. It's a thing that we do not need anymore. So let's have a look at our main page.xaml button text is binding to counter text. So we don't need to do that. We'll just get rid of that binding and we'll just say find a poo bin. Find poo bin command. So there we go, find a poo bin. That won't work at the moment because the binding we're suggesting there does not exist. Let's go back and change the command binding. We don't have counter text anymore. Find poo bin command on find poo bin. So in here we say underscore route calculator. So that's fine. Let's say var start location equals let's do it like that. So that goes into the location service and just gets our location at that point. We then need to just go to the bin location service and just take the first bin that we find. So there we go. What we can do is, if we go to our root location, let's have a secondary constructor for this. Oh, I see. Right. Yeah, let's do that. Perfect. So we can initialize it ourselves, or we can pass in a location like that, which just makes it that much more useful for us when we call it in here from the view model. We can just say start location and end location. That was very fast. Let's take that response. Let's take those classes, and we've gone back here into Visual Studio. So I will just pop them in at the end here and make them subclasses within that. I think it probably makes sense to do that. I may regret this, but let's try that. So we've got here we will say var response JSON equals that, and then we are going to deserialize what we want from that. Okay, yep, it guessed again. And we'll just return empty string for the moment. So obviously in the next step, we need to go through the data that's encapsulated by that root and the classes within it and convert that into the actual root type that we want to return. So the root is the overall distance for the root and the collection of waypoints. So let's just test this first, and then we'll go on straight on to doing that. Let's set a breakpoint on the one before, just in case serialization fails, so we can quickly find that out. Click on Find a Bin. So we've got our response JSON. Let's step over that. And inside root. Okay, so that didn't work. It's probably to do with the JSON serializer options. Let's just create JSON options equals new JSON serializer options. Property name, case insensitive. Create a field for that, and JSON options here. Let's run that again. Oh, we have a royal visit from Captain Scrunch. Hello, Captain Scrunch. What have you come to tell me? Hey, what have you come to tell me, mister? Have you come just in time to see this work? And he's gone again. Step over. Yes, features count as 1. Our first feature, we have distance, 943 meters. Geometry, we have 14 coordinates. Brilliant. I think that's great. I think that's done what we expected. The last thing we need to be able to do here is to convert that into our actual route, which can then be used later on the user interface side to plot that route over the top of our map as a new map layer. We have our route type, which has our list of waypoints, which are route locations, and total distance. So it's fairly trivial to do what we want here. Private. Okay. I'm still getting used to this thing. It's just like suddenly doing everything for me. So it's saying we take in the route JSON, deserialize like we just did, throw an exception if anything's invalid about that route that gets returned to us. Route features 0 coordinates, and then we project those coordinates into route locations, convert that to a list, get our total distance. I think that's it. That's exactly what we need. So here we just say we are changing this. So it's not a task of string anymore. It's a task of route. We'll just use the null propagation again here. So this is may or may not return a route. This is a task of route. So we've got our JSON. We just need to return pass route of a response JSON and get rid of the bit above. If we now go back to our main page view model, we can set a breakpoint on that. And our result is a route. Total distance is not set and waypoints is incorrect. Bugger. What went wrong there? Okay, so our JSON, just double check the JSON came back. It does look like what we expected to see. Features, geometry. Yep, that's what I would expect. So let's deserialize that. Route, features, geometry. We've got 14 coordinates. Total distance is correct. How did I get this wrong? Oh, calculate route async is still giving us this placeholder implementation. Dull. Worth doing. We just double checked everything worked fine and we can delete this line of code and just say return a result. So this is calculating the route when we have a single start location, a single end location. The final thing I want to do in this is where we have multiple potential end locations, and what we then need to do is calculate the route for each combination of the start location to one of those end locations, work out which is the shortest, and then return that one. That's the route that we want to use. So it's the shortest route to a POOBin. So let's do that now. We can basically expand from this one and say, calculate end locations var shortest route equals end locations dot select. We'll get it as a set of tasks and then do a task dot wait all, wait for them all to finish, and then we can select the shortest out of those. Wait task dot wait all. So when all? Yep. Okay, so basically this is returning a task for each of the calls to call open service async. If we use task.whenAll, that converts that set of tasks into a single task of the enumerable of the results. So if we look at shortest route, or an array of the results in this case. So once all of those calls have completed, we've got this. So we can now just say result equals shortest route, where route is not equal to null, order by route properties summary distance. No, that's not correct, but well, let's just accept that. It's just route.distance, isn't it? Total distance. It may not be null there. We know it's not null because we've already filtered it there. So both of these, it's possible for the route to be null. So that's good. That should give us what we want. We now just go into the view model side and we will get all of the bin locations, convert all of those into route locations and make this call based on that. So we should now be able to get the shortest route out of all of those routes. We'll kick a breakpoint here so we can see what we get back. This is incorrectly named. Candidates. Go to our main page view model and where we had that. So we are going to get all bins. We're going to select and return bin to new route location for that bin. And locations. We're going to need to add that to the interface, aren't we? And that as well. Calculate shortest route and locations. It needs it to be an array. Check we build. We do build. Let's run it. This should be good. Clear that breakpoint. We didn't want that one. Let's just let it carry on. So we have our set of candidates. We have 6 candidates. So it looks like that was the shortest distance, 329.1 meters, with only 7 waypoints in it. That got selected. And there we go. 329 meters, and we're at our nearest poo bin. That's brilliant. We have the groundwork laid now for plotting our routes on the map. But now it's time to pause for coffee. Let's be honest, there's a lot of pressure in tech to know everything. Every cloud provider, every library, every framework nuance and obscure parameter. But the truth is you really can't and don't need to know it all. What matters more, especially as you gain experience, is knowing what exists. I might not remember the exact syntax to draw a polyline on a map today, but I know it's possible. I know I've done it before, or I've seen it done or read about it. That tiny mental breadcrumb, the knowledge of how a similar library on another platform works, that's often enough. Because once you know something exists, you can look it up. You can reason your way back to it. You've got a thread to pull. So if you ever catch yourself with imposter syndrome because you can't recite method signatures from memory, get over it. You're not a worse developer for needing to look things up. You're a better one for knowing where to look. Now let's see if I can get this logic working on the first try. As always, please like, comment, subscribe. I really appreciate any feedback. So here we are in our project, and the first thing to do, I think, is to just do some basic refactoring. Things, for example, like the counter model. I do not believe we are using that anymore. There's 3 references, but I don't think it's actually used. Let us get rid of those instances, and then we can just delete counter model itself. Forgot one. Secondly, I don't like the fact that we've got lots of things called location here, and I think this one, route location, is actually just being used as waypoint. So why don't we just rename that to waypoint? Here's a list of waypoints. Yeah, that looks much better. Next up, in the data initialization service, we've got this class here. I don't want it to be there. Let's move that out into the models directory. Yeah, let's do it first like that, and then move that over to models. Yes, please. So I don't know what's going on. It seems to be messing around with line endings at the moment. So let's just let it fix all of that. Yep. So pbin finder models, bin locations data. That's fine. Let's try building. Make sure that can still be found where it needs to be used. So the next thing is, in preparation for unit testing, I think we need to, because this is we're building for Android and iOS, it introduces difficulties in adding this project as a reference to the unit test project to allow us to do the testing. So I think it makes sense to extract all of the logic that we would expect to normally be testing, things like our models and our services, into a separate project, which can be just a standard .NET 9 class library. And then when we add the unit test project, we can refer to that project and do our testing that way, and try and minimize or completely remove any tests that we need to do of the specific Android and iOS projects themselves. So let's do that. Let us go here and create a new project. It's going to be a class library, and we will call it pbinfinder.core and make that .NET 9. Click create. We can delete this class that it creates for us. Now let us go to pbinfinder, add a project reference to our pbinfinder.core, and then let us start bringing stuff across. So let's create a folder for the services. Let's start off with bringing across the most recent one we've done, the root calculator service. Try and drag that into there. Okay, yeah, so it needs the models to come across here as well. So let's just crack on with that. We'll have to do it all in one go. Add new folder for models. And we'll do that for each of them. Oh, for that one it has done it. What? It's fighting me a little bit for this, but let us just make sure it works correctly. Location is, so what is location? It is in sensors location. Oh, that is really disappointing. Okay, so I've refactored the waypoint to remove the location which is tied into the user interface code. So we'll just have to initialize that in a different way when it's needed. So that means that we've got everything in terms of our models, and the root calculator service is refactored out into this pbinfinder.core. Let's fix that like so. New waypoint, start location. So instead, we can just say start location dot, which way around is it? Latitude and then longitude. Let's check that that still works. Put a breakpoint in the root calculator there, and then let's run that up. And the result is what we saw before. Perfect. Okay, let's stop that down. And now we need to create the test project. So let us add one more class library project. Add new project. Class library. It's going to be called pbinfinder.tests. Who could have guessed that? And it's .NET 9. Create that. Let's add some NuGet packages. XUnit. Okay, that's happy. So what I can do now is if I go into here and have a look at our root calculator service, I wish we did have open anyway. I won't get into what we can do about testing something that actually calls out to a real HTTP service. There's ways and means of injecting libraries that can deal with going and getting stuff from a URL, which can then have test frameworks injected into them to allow us to do that sort of level of integration style testing. But we don't really want to do that here. We don't need to. What we can do is look at something like this parse root method where we're deserializing and then converting that into a different structure. That's the sort of thing that can easily be unit tested. We'll need to get it to change to internal and deal with internals visible to and that sort of thing so that the test project is able to reach in and call this one. But let's, first of all, let's just make sure that the test project has got a project reference to the core project. And then what I can do is let's go and create a new Copilot edits window, Claude Sonnet, and say, can we add a unit test for this parse root? Internal is visible too. Change visibility to internal. And a number of different test cases there. So let's tab to accept that. Needs XUnit. We build. Now let's run all tests. We need like test runner. I can never remember how to do that, so we can always try asking Copilot. Let's accept that, save that down, and try running all tests again. Okay, so excellent has found the tests, but a couple of the tests are failing, so let's have a look at that. What's going on there? So, an invalid JSON, it's expecting to return null. I'll tell you what, let's dock this down here where we can easily look at it. Give us a bit more space to see what's going on. Okay, so basically it is just the fact that we don't really catch any exceptions when we are passing that JSON, which makes sense. So let's go into parse root and we can see that we are just doing the deserialized. There's no exception handling on that. So we can add a try catch around all of this. Tick that. For the moment, we'll just handle the JSON exception itself. Save that down, rerun the tests. So that one passes, but the one where it is getting a null reference exception failing at line 79 in parse root. Okay, so it's the fact that geometry is null and we didn't check for that there. So once we know that it has something in it, we can say root.features 0.geometry equals null and check for that as well. A bit unwieldy. I mean, in reality, we'd probably want to work on this a little bit and make it a bit nicer, but it is what it is. It's just enough for this demonstration. And all test pass, we are good. So I think that's fine for now. We've shown the pattern for introducing unit tests into a .NET MAUI project. So it would be a matter of bringing more services across. anything else across that doesn't have to live within the actual user interface project or the main application itself, we can bring across to our core project and then add unit tests off the back of that. We've refactored this. We've added unit tests. We now have our routes coming back from the root service. We need to display them on the map. So let's get on and do that. Right. So now we're at the stage where we want to start plotting our route onto the map. What I've done is brought up here the notes that I was previously looking at in ChatGPT when I asked it to do the research. So let me just share the screen with you so you can see that. So as we can see, the first thing we need to do is to convert our geometry in terms of the route points using that same spherical Mercator projection that we used previously to build up a polyline. Then that line is used to create a feature for the map, and it's given a style. And then finally, we create this memory layer, which is called the route layer, and that's going to have our set of route lines plotted on it. So let's go across to Visual Studio and see what we can do with that. Here we are back in Visual Studio. So what I'll do is have a look at our view model code. And scroll down, we've got our on-find poo bin, which is where we get the route back from the route calculator service. So this is where we need to inject the code that we were looking at there. So let's just dump it right in here, and then we can refactor that a little bit later. So let's see, we've got geometries, and of course it doesn't exist. It's been made up by ChatGPT. I don't know what was wrong with the so-called deep research that ChatGPT done for me in terms of how to draw the polylines in MAUI, but it was completely wrong. I don't know if it's like hallucination or just based on an older version and the API has completely changed since then. Who knows? But what I'll share with you now, I found within the MAUI documentation, what I found is this, which is a line string sample. So doesn't sound exactly like what we wanted, but actually it is what we wanted. I find the documentation for MAUI is a little bit hit and miss. For MAUI, they've got the API documentation. It's like quite thorough. It's covering everything, but there's no, in the documentation, there's no obvious how-tos or proper getting started guide. They've got a getting started, but all it does is shows you how to get the OpenStreetMap added, and then that's it. You're on your own after that. So what I've done here is sort of dug into some of the samples, and luckily I came across this one basically by searching for polyline, and it seems to do what we want. So basically we can see this create line string layer, and it's using this line string based on a set of coordinates. It's using the Mercator projection for that. They're defining the line string in line like this, but I think we can adapt that to work with the route waypoints that we've got. So let us just copy this over and dump it in our code and see what happens. So inside of our on-find poo bin, let's drop that in. So we don't want to do that, but we are saying a new line string, which is coming from result dot waypoints dot select. Then from long lat, which is v dot longitude, v dot latitude, to coordinate. It doesn't know what that is. Let's bring in that using statement, and then we can just say our line string. Okay. We just do it inline. So just copy that bit. That's it. And then let's go with width is 6. Oh, no. So we want to say var root layer layer. Gosh. Call that root. And then we can say at the bottom, map model layers.add root layer. Lovely. And we need to do this thing again. See if we build. We don't build. Oh, hang on. Net topology suite, geometries location. Okay, so it's built, it's brought in some other version of location. And we wanted Microsoft MAUI devices, sensors, location. Copy that warning. Let's go up here and say using location equals like so. Possibly null. Oh, yeah, that's fair comment. The result could be null. If result equals null, then just return. Nothing we can plot if we didn't get a root. Obviously, at some point in the later in a later version, we might have some proper error handling here, so we display to the user the fact that we were unable to fetch the root from the server, or we weren't able to get the location. So yeah, rather than not doing anything when they press the button, we'd give them some sort of feedback. And let's see what happens. Let's run this up. And we have what we expect to see. Let's find a poo bin. And there we are. We have a root plotted. Just like that. It took a little bit longer than it seems, but yeah, there we go. Very nice. So there we have it. We're fetching our root down from the API and successfully displaying it on the map. The dogs cannot be anything other than superbly impressed by this. So let's go and show them. Right. I'm back in the boardroom and I am determined to make a complete and professional demonstration of this app to the stakeholders this time. Please send in the stakeholders. Okay, so take a look at what happens when I click the find poo bin here, Mr. T. See how the line appears to be showing our route, and look how the locations around the trail. Captain Scrunch. Okay, right. Captain Scrunch. See how
See how the location tracks along the route? Can you see that, Mr. T? And you've knocked the app off. Well, they never seem impressed, but we all know this app is starting to become useful, and that's what counts.
That's our app officially one step closer to solving an extremely specific but very real problem. It now tracks you, finds the closest bin, and politely suggests where to walk. Is it perfect? Absolutely not. But it's working, and Mr. T seems impressed, to be fair. Or at least less disappointed. In the next and final part of this series, we'll go one better. We'll let you add new bin locations, store them in an online database, and optimize how we load the bins based on the location. A bit more cloud, a bit more logic, and as always, 2 golden retrievers judging my code. If you enjoyed the journey, like, comment, subscribe, all that stuff, and no matter what, thanks for watching. We'll get live location updates, work out the closest bin, and even draw a little route to it, so your dog isn't left impatiently while you get on, she's gone.